Example 4 for the shell method. Once again, we're given a region and we're told how to revolve it. In this case, we want to go about the y equal -3 line. Now, I've already drawn the figure, so I'll just go through the steps here. With this line y equal 2x minus 4, I started 4 units down, had a slope of 2, so up 2, right 1, up 2, right 1, up 2, right 1, through the line. I have a line of y equals 0, which is the x-axis, and the vertical line of x equal 3, which just gave me this little triangle right here. That's the region that I want to revolve about the line y equal -3. And so to set this up using a shell method, I can state that my volume would equal, because this is going about something that is similar to the x-axis, it's parallel to the x-axis. For a shell, it means everything has to be in terms of y. So I can go integral, I'm guaranteed that this has to be a dy. And so I have to figure out where to start and where to stop on my regions. Well, since this line was y equals 0, and it intersected up here at 3, 2, I know that I'm going to go from 0 to 2. From y equals 0 to y equal 2 for the figure. I have my 2 pi. Now, as I look at this, I'm going to turn the paper sideways. Bear with me for a minute. I have to figure out the distance of this radius. If I was just here on the x-axis, I know I'm going upward. I know I'm going to the left, but that's upward on the graph. Upward, that would be y. Because I'm at the -3, I have to include that as part of my radius because I'm revolving from here. So this would be an entire distance of 3 plus this y that I'm revolving. So this is going to be a distance of 3 plus y. 3 plus y, which you could write as y plus 3 or 3 plus y, doesn't matter how you write it. So my radius would be 3 plus y. And then that height, once again I'm looking at this, the height would be that line, that horizontal, vertical line, minus the slanted line. So it's going to be 3 minus whatever this line is in terms of y. So I'll start this here, I'll say 3 minus. Now I do have to do a little bit of math up here because this has to be in terms of y. So if I have y equals 2x minus 4, I can say y plus 4 by moving the 4 over equals 2x, and then I can divide by 2. So I can call this 1/2 y plus 2 is equal to x. And that's what I'll put down here then, because I had to go the line y x equals 3 minus this line x equal 1/2 y plus 2. So when I subtract that, again, pay a particular attention to your signs. Be careful with your distributing. This would be minus 1/2 y, then minus 2, because I have to distribute that. And then of course from here you can simplify it. I'm not interested in doing the algebra for you. You should be able to do the algebra. I just want you to see how to set up that shell method. So I've got my 2 pi, my radius, my height, and the d. Because I wanted to go x-axis or parallel to the x-axis, this had to be a dy. It's the opposite of what you traditionally expect. Radius we'll describe one more time. If my axis of revolution was here at y equal -3, I had to travel 3 units before I could even start with my y value, which was to the positive, the upward side of the x-axis. So it was 3 plus y. You could have wrote it as y plus 3 or 3 plus y. And then I had to consider my height of this region here. And the height was going to be rightmost minus leftmost. So it had to be x equal 3 minus x equal 1/2 y plus 2. Of course I had to simplify it. So that was my setup. 2 pi radius, height, dy from y equals 0 to y equal 2. And that is your fourth example for the shell method.